All right, ladies and gentlemen, right now I'm in Arizona. I'm missing you guys so much, but please do your best to understand the contents of the video, to go into class tomorrow, to be prepared to get your work done. Just a reminder that there will be an open note quiz on this material the Monday I return. I'll be checking for completion of the worksheet, and you'll be able to use that to help you take the quiz. So our first video is introducing the 5 types of reactions. So first things first, what is a reaction? A reaction is anything where we have a recombination of elements. And this can occur in 5 ways that we're going to study to start out with. The first is, in your reading, it's called a combination reaction. It's also commonly known as a synthesis reaction. To synthesize means to make something, to create it, and combination implies 2 things coming together to make one. And it just so happens that this is exactly what a combination synthesis reaction is. You have 2 or more reactants that come together in a single product. So how do you determine whether it's a synthesis reaction? There's one final product. Anytime you have one final product, it is going to be a synthesis reaction. So if I ask you to identify it, you want to look, is there one final product? Decomposition reaction would be the opposite of a combination synthesis reaction. If you notice here, you start with one reactant and you end with 2 or more products. So essentially a decomposition, if you think of something decomposing after it's died, it's breaking down into smaller parts. So a key sign that you have a decomposition is you have one initial reactant. Okay, so to start out with, we actually have two very simple reactions to identify. Combination synthesis, one final product; decomposition, one final reactant. Okay, a single replacement reaction is also known as a single displacement reaction. It kind of is inherent there. The idea of replacement or displacement means that single, one, replacement, displacement, something is going to be moving. Now, I like to call this the Hussey reaction. No, I will not give you credit if you put that on the test as the name. I only take single replacement and single displacement. But the Hussey reaction, the reason why I call it this is the following. If you notice here, initially A is all alone, and A is who I call the Hussey. And what you notice is in the product is A has stolen C away from B. So in a single replacement reaction or single displacement reaction, one initial reactant that was alone bumps off one of the reactants and essentially steals away the partner of that particular reactant. So a good way to remember this is as the Hussey reaction. And a lot of students find that particularly helpful. The 4th type of reaction that you all are going to talk about is very similar to the single replacement, single displacement. But instead of a single replacement, this one is a double replacement. And so as you might guess, instead of one replacement going on, there's 2 replacements going on. I also call this the do-si-do reaction. So if you've ever seen people like square dancing and they kind of switch partners around, it's similar to what's going on here. So initially you'll see 2 reactants pair together, 2 products pair together, and they'll essentially flip-flop. So if you'll notice, A and D are now linked together in the product, and C and B are finally linked together in the product. So basically, what we see here is a do-si-do or a switch. And that's a good way to recognize a double displacement has occurred. The nice thing about these reactions is they sound very, very similar to what is actually happening. The final type of reaction is probably the easiest to identify because one of the reactants is usually the same and 2 of the products are usually the same. So for example here, in a combustion reaction, what we will always see is this oxygen present. So anytime that oxygen is a reactant, that is a sign that we have a combustion reaction. Now another sign is that most combustion reactions also have water and carbon dioxide as a product. But if we see oxygen as a reactant, we can always call it a combustion. So what I'm going to ask you to do tomorrow in class is be able to identify whether a reaction is a combination, synthesis, a decomposition, single replacement, single displacement, double replacement, double displacement, or combustion reaction. And you can, of course, rewatch this video in class. Please email me if you have any questions, or feel free to shoot me a text message if you have a question on a particular problem, and I'll help you any way that I can. All right, y'all, have a great day, and I miss you. Bye.